our measures, in a collection of the data, organization of the data, that is classification, tabulation, and presentation of the data. And yesterday we are covering the first step or foundation of the statistical analysis or quantitative analysis that we used to do in case of our business or economics or management studies, that is your measures of central tendency. That indicates that which, that means how can we represent our entire data set by using a single value. That means describing your data by using a single value. We were trying to do that yesterday by taking into or by calculating certain measures of central tendency like mean, median, mode, and so on and so forth. So today we will be discussing on a certain measure that is called as your variation, or else we call it as measures of dispersion, which indicates that it may so happen that you are given with two series of data. When you are calculating the mean of the two series of the data, it is one and the same. But there may be some difference, like suppose say the score of the MS Dhoni that he has made in 10 innings is equal to 500, and the score of another may say Sachin Tendulkar in 10 innings, it is also 500. But in that, in MS Dhoni's, there are certain like 80s, 90s, and he has done more in 80 and 90s only. Whereas in case of Sachin Tendulkar, you may say that he has done 100 and somewhere it is 0 and somewhere it is 40 and so on and so forth. In that case, suppose if somebody will ask you which batsman is more consistent. In that case, it is required that we should have one more measure which will speak about how can we measure or how can we determine that which product is consistent in the market and which is not that consistent in the market. So for the purpose, we are having a technique in our quantitative techniques that is called as your measures of variation. So the basic objective of this particular session is that how explain the concept of dispersion and variability in data and why it is important in statistical analysis. We will be discussing that. Then we will be identifying the measures of several variations like mean deviation, variance, standard deviation, etc. And we will be performing certain calculations, basically the standard deviation calculation, basing on which you can be in a position of calculate the variance also, and we will be performing the calculation of your standard deviation and interpreting the skewness, and we will discuss a little bit about how can we apply this in our business contexts. So moving forward, what do we mean by variation? By variation or dispersion, we mean the extent to which the data values differ from mean or from each other. That is, while measures of central tendency, say mean, median, mode, which describes the center of a data set, they do not indicate how spread out the data are. Suppose say two data sets have the same average but different levels of variability. So to determine which data set is having highest variability and variation or variation, and the which one is closely clustered around the mean, to determine that we have to determine that whatever the technique we are using, that is called as your variation. So understanding the variation helps analyze consistency, risk, and differences in outcomes in fields such as business, economics, education, and psychology. So your essentials of good measures of variation, you may say the measures of dispersion are used to understand how widely the data values are spread around the average. The measures of central tendency alone cannot fully describe a data set. So to describe a data set fully, we need to have more measures. And one of them is your variation. So to measure the data spread, the basic essentials of a good measure of variation is to measure the data spread. They should show how far the observations are distributed around the mean. And number two, to understand the consistency, low dispersion indicates the stable or consistent data, while high dispersion shows large fluctuations. So to compare two different data sets, two data sets may have the same mean but different variability. So dispersion helps compare their reliability and stability. And to support your decision making in business and economics, dispersion helps in assessing the risk, uncertainty, and performance variation. To understand distribution characteristics, it should measure the essentials for studying your skewness, kurtosis, and overall distribution C. So here there are several measures of variations which can be classified into basically two. One is your absolute measures of variation and one is your relative measures of variation. By absolute measures which express dispersion in the same units of the data as the data. That means if your data is tons in tons, then your absolute measure will be in tons, and if it is in kilometers, then it will be in kilometers, and so on and so forth. So they show the actual magnitude of variation within a data set. So examples may be your range, quartile deviation, mean deviation, variance, and standard deviation. So example, suppose say if the height of 15 students vary by 15 centimeters, the dispersion is expressed in centimeters, the same unit as the data. So by relative measures of variation, relative measures express dispersion as a ratio or percentage which doesn't contain or which will not be having any unit associated with that. They are usually useful for comparing variability between different data sets. That means each of the relative measure of variation, they don't have any unit associated with that. So it is free from whatever the unit it is with the data set. So examples may be your coefficient of range, coefficient of quartile deviation, coefficient of variation, and coefficient of mean deviation. So if two companies have different average profits, the coefficient of variation helps determine which company has more consistent performance. Okay, so absolute measures, differentiating between the absolute measure and the relative measures, we may say that absolute measures they express dispersion in original units, whereas your relative measure it is in ratios and or percentages, and it is not measured or it is not expressed by using any of the units. The absolute measures they show actual spread of the data, whereas it shows the comparing different useful, but it is basically useful for different data sets. Example of your absolute measure may be standard deviation, and over here it is coefficient of variation. These are the two measures of variations like standard deviation and coefficient of variation, which are most frequently used in while making your data analysis. So absolute measure, your range is the simplest absolute measure of variation. Number one is your range, which is the simplest measure of variation, and it shows the difference between the highest and lowest value in the data set. Okay, that means maximum value in your data set minus minimum value in your data set. It speaks about the range of the simple measure of variation of that particular data set. Okay, so it is the formula is x max minus x mean by x max, maximum value in the data set, x mean is minimum value in the data set. So suppose say This is one run scored by a player in 5 matches. Then the range of this particular data set, the maximum value in this data set is 80 and the minimum value in this data set is 25. So the range of this data set is 55. So again, while that is, so this one is for your ungrouped data. If it is grouped, that is if you are defining it in, or if your data is represented by using class intervals, then, or a frequency distribution, then it is called as grouped data, that we have already covered. If we are representing our data or tabulating our data as a frequency table or frequency distribution, then our data is grouped data. So if our data is grouped data, then how can we calculate the range? For that, we are having two sort of formulas. The formula one is the first standard method for estimating range of group data. It uses the extreme class limits of the frequency distribution. This method determines the widest possible spread of the data set based on the lowest and highest class intervals. Okay? It assumes that smallest value in the data set lies in the lower limit of the first lowest class and largest value lies at the upper limit of the last highest class. Okay, lower limit of the first lowest class, first class that is lowest, and upper limit of the last class that is the highest. That means upper limit of the last class and lower limit of the first class. Okay, the range of the group data, the formula is U max minus L min. So the components of this formula are precisely defined by the boundaries of the data set. Okay, so U max represents the upper limit of the highest class interval, representing the maximum possible value in the data set. Okay, and L min represents the lower limit of the lowest class interval, representing the minimum possible value in the data set. So this method provides the maximum possible estimate of the range, as it considers the entire span of the values defined by the class boundaries, the lowest limit of the lowest class, first class, and upper limit of the last class. Okay, so it is useful when analysts want to understand the full potential spread of the data within the grouped frequency distribution. Sure. Making an example, so we will be using these two formulae and and calculating the range. So another formula, or you may say the formula 2, is over here. Your method for estimating the range of group data is based on midpoints of the extreme class intervals. Okay, so this approach assumes that the observations within the class intervals tend to cluster around the midpoint of the interval. Okay, therefore, using midpoints provides a more representative estimate of the data set rather than relying solely on the outer class limits. That is, range is equal to midpoint of the upper class limit and midpoint of the lowest class interval. Sorry, midpoint of the highest class interval and midpoint of the lowest class interval. The difference between the two, it speaks about it gives you the range or an estimate of the range. So this method often produces a smaller and more realistic estimate of the range compared to the extreme class interval method. Okay, so it reflects the assumption that most of your data values tend to be concentrated around the center of each class interval. So only over here the midpoints of the class intervals are taken into consideration rather than the boundaries, as in case of our formula 1. So if this is my example, So basing on my formula 1 and formula 2, we will now be calculating the range. So to solidify our understanding, let us apply both formulas to this practical example wherein it is a score of the exam, in an examination by 40 students. Okay, that this performance data is efficiently summarized in this particular frequency table. Okay, so now by using the formula 1, to apply the formula 1, we must first locate the absolute outermost boundaries of the data set within the frequency table. So highest class interval over here is 91 to 100. Okay, so 91 to 100, therefore the maximum possible score is 100. But lowest class interval over here is 51 to 60. So the lowest score or minimum possible score is the lowest limit of that particular class interval, that is 51. So substituting these two values in our formula 1, that is U max minus L mean is equal to 100 minus 51, and the range of this particular group data as per my formula 1 is 49. Okay, so the estimated range for this student exam score is 49. This suggests that maximum potential spread of 49 points across the entire class performance. Whereas if I'll be using next, I'll be using the formula 2, that is by taking into consideration the midpoints of the class intervals. So over here, midpoint of the highest class interval, that is 91 to 100, is 91 plus 100 by 2, that is equal to 95.5. Whereas the lowest class interval midpoint is your 55.5. So by substituting these two values in my formula of midpoint max minus midpoint mean, it is 95.5 minus 45.5, and range of the group data is 40. The result, that means the result that we are obtaining from formula 1 and formula 2 are not the same. Okay, the result is narrower but reflecting the assumption that the actual scores are concentrated closer to the center of the respective extreme values. So comparing the formula 1 and formula 2, it speaks that because the formula 1, it considers the outermost values of the data set, it gives a larger range. Outermost possible values, that is upper limit of the upper class and lower limit of the lowest class. So your range value is larger in comparison to the formula 2. So the selection of the appropriate method depends on the purpose of your analysis and the assumption about the distribution of the data within the class intervals. So while both approaches are statistically acceptable, they provide slightly different perspectives on the variability of grouped data. So depending upon the requirement, depending upon your distribution, you may select either formula 1 or formula 2 for calculating your range, and both are statistically correct. And more accurate interpretation and reporting of statistical results, you may take the differences. So next is the relative measure, that is your coefficient of range. It is a relative measure of dispersion and it expresses the range as a ratio and making it useful for comparing variability between different data sets. It is L minus S divided by L plus S. That is, L is the largest value in the data set and S is the smallest value in the data set. It is 80 in our, so if your largest value is 80 and smallest value is 20, then your coefficient is 80 minus 20 by 80 plus 20, that is 60 by 100 is 0.60. So this coefficient of range provides a standardized measure of dispersion, allowing comparison of variability between different data sets. So next, again, average deviation, or it is otherwise called as your mean deviation. It is one of the absolute measure of your dispersion. So absolute, it is the average of the absolute differences between each observation and a central value. Usually that central value may be a mean or median. Okay, that is average deviation or mean deviation is equal to absolute value, that is x is the individual observation minus a that you may consider as mean or median divided by the number of observation. By absolute deviation, I mean we will be taking into consideration the deviation ignoring the sign, positive or negatives. If my data set is 4, 6, 8, then my mean is 6 and my deviation is minus 2, 0, plus 2. So absolute deviation will be 2, 0, 2. So sum of the absolute deviations is equal to 4. The average deviation is 4, that is by 3. Okay, so average deviation indicates how far on average the data values deviate from the central value. Again, with your average deviation or mean deviation associated with one more relative measure is known as the coefficient of average deviation, and it is obtained by dividing average deviation by the central value, maybe mean or median. For example, coefficient of the formula is coefficient of average deviation or mean deviation is equal to the mean deviation divided by mean or median. If the average deviation is calculated from the median, then the coefficient of average deviation is obtained by dividing the average deviation by the mean. Although average deviation is a useful measure of variability, its practical use is somewhat limited. It is mainly applied when the objective is to measure and compare variability among different data sets. And major limitation of average of deviation is that it lacks strong mathematical properties. And as because it is considering the absolute deviations, that is, it is ignoring the positive and negative signs of the deviation. It is not suitable for advanced algebraic and statistical analysis. So it is a very raw measure of dispersion. So next is your standard deviation, which is the most appropriate measure of deviation and which is having a most applicability or is used as the best measure of deviation in almost all the statistical analysis from here and further onwards. So it is the most widely used measure of dispersion. It indicates how much the observations deviate from mean on average. A small standard deviation shows that the data values are closely clustered around the mean, while a large deviation indicates that there is a greater variability in the data set. Okay, standard deviation formula, maybe if it is population, then it is sigma is the notation that is used for standard deviation. Population standard deviation is sigma and sample standard deviation is S. It is square root of sum of all the values, that is x, minus mu, that is mean of the distribution, divided by n, that is the total number of observations. And similar is the case with the sample. It is square root of x minus x bar, sum of all the observations. X minus x bar is the sample mean and n is the total number of observations. Over here it is n and over here it is n minus 1 y. Note that both formulas look almost similar except for the denominator, which is n in case of population standard deviation, but n minus 1 in the case of sample standard deviation. So while calculating the sample mean, all the data values in the population are not considered. So the sample mean just is an estimate of the population mean. But this introduces some uncertainty or bias in our calculation of standard deviation. To adjust this, the denominator of the standard sample standard deviation is corrected to be n minus 1 instead of just n. Okay? As because we are not calculating the sample mean basing on all the values of the population, there may be, it is not the exact population mean, it is an estimate of the population mean. Okay, so the estimates may contain certain bias. So to eliminate that bias, to make our standard deviation estimate to some extent very correct or very near to our population standard deviation, our standard deviation is corrected to be n minus 1 instead of n. This particular correction is known as Bessel's correction. Okay, so formula for calculating standard deviation. A population, as we know, a population is an entire group we are interested in studying, while sample is a smaller group of individuals that is taken from the population. The formula to calculate standard deviation of population and sample are different, we have already considered, and this is for your population standard deviation. So sample standard deviation is this. Okay. So calculating the standard deviation for ungrouped data, the calculation for standard deviation differ for different data. So the distribution measures the deviation of data from its mean or average position. In this method, we first compute the mean of the data values, then compute the deviations of each data value from the mean. Then we use the following standard deviation formula by actual mean method. Okay. So consider, suppose say our observations on grouped data 3, 2, 5, 6. The mean of it is 3 plus 2 plus 5 plus 6 by 4, that is 16 by 4, that is equal to 4. The sum of the squares of the differences, that is x minus x bar. So as we are having 3, 2, 5, 6, so 4 minus 3, 4 minus 3, it should be 3 minus 4 or 4 minus 3, the one is the same. And 2 minus 4, 5 minus 4, 6 minus 4. So 1 square, 2 square, it is 1 square and 2 square. That is 1 plus 4 plus 1 plus 4. Okay, 4 plus 1 plus 4 plus 1 plus 4. 8 plus 2 is 10. So variance is squared differences, that is this divided by n. Okay, n is our total number of observations. Total number of observations over here is 10 by 4, that is equal to 2.5, and the standard deviation will be 2.5. Square root of that is equal to 1.58 approx. Okay, so the standard deviation of grouped data. So for grouped frequency distributions, standard deviation is calculated using the class midpoints and their corresponding frequencies. It measures how widely the data values are spread around the mean. So for n number of observations, suppose say x1 to xn, and the corresponding frequency is f1 to fn, the standard deviation is square root of 1 upon n summation of fi into xi minus x bar whole square. So where your f represents the frequency of each class, fi is the f1 is the frequency of the first class, x is the midpoint of each class interval, x bar is the mean of the distribution, and n is the total frequency. So suppose say we are having the data like this. Xi is 6, 10, 12, 14, 24, and the frequency is 2, 3, 4, 5, and 4. Then mean will be 6 into 2 plus 10 into 3 plus 12 into 4 plus 14 into 5 and plus 24 into 4 divided by the total frequency, that is 5 for 9 for 13 plus 3 16 to 18. So that is coming around 14.22. So when calculating the standard deviation, we will say Fi is like this. If X, we will be making a table with this many columns. In one column, we will be having all our individual observations, or this may be your midpoint of the class intervals. Okay, and this is the frequency of that particular class, and this is midpoint of the class interval and the frequency of the class. And we will be adding up this and adding up this. Then xi minus x bar, we have to make xi minus x bar is, in the previous slide it is there, that is 14.22. So by doing that, we will be getting this column. Then the square of each. Then multiplying this with this. Okay. So your sigma will be 1 this divided by 18, the square root. That is the square root of 32.83, and that is 5.73. So this is how we calculate for a class interval. So again, one more example for your ungrouped data. As because this is the most important one, so I have taken many examples. And over here it should be square, it is over here 2. Okay, by n1. So there are 39 plants, and we will be calculating our standard deviation by following the same formula, that is square root of summation xi minus x bar whole square divided by n1 and square root of that. And it is coming around 15.5. Sure. By taking the class intervals, how can we calculate? So to calculate the standard deviation of group data, we follow a structured procedure using the frequency distribution table. The standard deviation measures how much the data values deviate from the mean. For grouped data, we estimate it using class midpoints. Okay, so the step 1 is, first of all, you create a frequency table with midpoints. And how can we calculate the midpoints? That we know pretty well. That is lower limit plus upper limit of the class divided by 2. Over here it is 10 plus 0 by 2, that is 5. Okay, over the next one is 20 plus 10 divided by 2, that is 15. 5, 15, 25, 35, 45. The frequencies are given is 3, 7, 8, 5, 2. Okay. So midpoints are 5, 15, 25, 35, 45. So now compute. Next is we are to compute the mean of our distribution. So how can we calculate that? So next you make Fi into Xi column and multiply this with this. 15 into 7 is 105, 200 into 25 into 8 is 200, 35 into 5 is 175, and 45 plus 2 is 90. So summation Fi is equal to 5, adding all this in this particular column, it is 585. and summation divided by the total frequency, that is 3, 7, 10, 18, 23, 25. So 585 by 25 is equal to 23.4 is the mean of this particular frequency distribution. The next step is to compute the square of deviation of midpoint from the mean. That is, we are next to calculating the mean 5 minus 23.4. Okay, and similarly 15 minus 23.4, 25 minus 23.4, 35 minus 23.4, 45 minus 23.4. Okay, then square of each. Then we have to calculate the frequency weighted square deviations, that is Fi into this by Fi into xi minus x bar whole square. Fi over here is 3, 7, 8, 5. So each column is 3, 7, 8, 5, 2 is to be multiplied. And this is my Fi into xi minus x bar whole square. Then compute the standard deviation, that is equal to Fi into xi minus x bar whole square divided by n minus 1, the square root, that is 3135.99 divided by 25 minus 1, that is equal to 130.666 square, and approximately it will be 11.43. And if you will be dividing it by the total population instead of n minus 1, then it will be 25 and it is 11.20. So the difference is very little, error is small. So interpretation, the standard deviation S indicates that the student scores typically deviate around 11.43 points from average score of 23.4. And the relatively large value reflects a moderate spread in student performance. Okay, so moving ahead. So if we will summarize all these steps, then as we know, let us move a little back again, repeating that standard deviation is how much your observations are deviated from the mean or the average of the distribution. Okay, so taking that into consideration, if yours is a frequency distribution or a grouped data, then what are the basic steps that we take while calculating our standard deviation? First of all, you take your table along with the class intervals and frequency. Then in the third column, you find the midpoints and note in that particular column the midpoints of each class. Multiply your midpoints by corresponding frequencies and sum to get the mean, and compute square deviations of midpoints from the mean, and multiplied your square deviations with the corresponding frequency, and then sum and divide with n minus 1 if it is sample or n for population and take the square root. This method generalizes to any grouped data frequency distribution. Okay, this is the procedure, or these are the steps using which you are to calculate your standard deviation if the frequency distribution is given. Or okay, So next, associating with your standard deviation, the relative measure of variation associated with it is called as your coefficient of variation, and it is denoted by CV. This measure is simply the ratio of standard deviation to mean expressed as the percentage. The coefficient of variation is equal to sigma divided by x bar, that is your mean, into 100. So when the coefficient of variation less in the data, it is said to be less variable or more consistent. So sometimes in the examinations, you will be given with the scores of several cricketers, or you may be given with the sales figures of several products. You may be asked to find out which product is more consistent in the market. In that case, basing on your sales figures, you calculate the standard deviation of your sales data. Okay, first of all, calculate the mean, then calculate the standard deviation of one product. Follow the same procedure to calculate the second product and to calculate the third product. And then you compute the coefficient of variation for each of your sales data and find out that which sales figures are having, which sales data is resulting with the minimum of coefficient of variation. The lesser the coefficient of variation, more consistent is your product. Okay, this is the basic use of your coefficient of variation. So if given with the several scores of the several players, if you are being asked that which player is more consistent, you take the score of that particular player in so many matches and calculate the standard deviation, then calculate the mean, calculate the standard deviation, and find out the coefficient of variation, which is equal to standard deviation divided by mean into 100. The percentage, this percentage figure will be, if it is less in comparison to the other player, then the player 1 is more consistent than player 2. This is the use of your coefficient of variation. Next is your skewness. By skewness, I mean the degree of asymmetry in a frequency distribution. It indicates whether the data are symmetrically distributed or skewed to one side of the mean. Okay, that means if you will be taking into consideration the graph of the distribution, whether it is the tail is larger towards the right or tail is larger towards the left. Depending upon that, you may say that your distribution is skewed, maybe. Okay, and in a symmetrical distribution, the values are evenly distributed around the center, and if the mean, median, and mode of a distribution are one and the same, and if these three figures are same, equal, in that case, we say that the distribution is symmetrical. And the example of a symmetrical distribution is normal distribution, the figure of, or you may say the graph of which is called as a bell-shaped graph. Okay. So this is what skewness is, basically a measure of asymmetry of a distribution. In other words, it tells you how off center a non-symmetrical distribution is. A left skewed distribution has a long left tail, this one. Okay, and is sometimes called a negatively skewed distribution because it is a long tail is on the negative direction in a on a number line. So if this is your mean, so your tail is towards the left of the mean, so it is long tail towards the negative direction. Whereas, and if that is the case, then we say it is left skewed distribution. A right skewed distribution has a long right tail and is sometimes called as, sorry, it is, sorry, it should be positively skewed because it is a long tail on the positive direction of the number line. Okay. Please read this negatively as positively. It is a typo error. Sorry. Sorry for that. I may please be excused. Okay. So a right skewed distribution has a long right tail and it is sometimes called a positively skewed distribution because its long tail is towards the positive direction of the mean. This is the mean and your tail is towards the right side of your mean, that is in the positive direction. Okay. And types of skewness that we said is symmetrical distribution. Number one, that means it is not zero skewed, or you may say not skewed. In this case, it is perfectly balanced distribution, we say, and in case of a symmetrical distribution, the mean and median and mode of the distribution are equal. Whereas in case of positive skewness or right skewed, that is your tail is towards the positive side of the mean, that is in this case your mean is greater than median is greater than, that is mode is the tail of this distribution extends to the right. Okay. As in this case, your median, in case of your right skewed or positively skewed distribution, your median will be more than your mean and mode is further more. Okay. That means mode is highest. Whereas in case of left skewed or negatively skewed, it is in the other direction. That is mean is highest. Okay. It is mean is less than median is less than median. Okay. So the tail of the distribution extends to the left. So this is your skewness. So importance, it helps to understand the shape of the distribution. It identifies whether your distribution is asymmetry, and the asymmetry is towards positive side or towards the negative side of the mean. So it is basically used in case of your or to describe your income distributions, market returns, business data, and the skewness indicates whether data are concentrated more on one side of the distribution and more on which side of the distribution. That is what your skewness indicates. So one more is your kurtosis. This is a measure of the tailedness of a distribution. Tailedness is how often outliers occur. So excess kurtosis is the tailedness of a distribution relative to normal distribution. The distributors with medium kurtosis, that is medium tails, are mesokurtic. This is mesokurtic. Then distributions with low kurtosis, that is thin tails, are platykurtic. Okay, thin tails. That is tails are less. It is more towards, very bulky towards the middle. That is platykurtic. This is medium, so mesokurtic, and It is high kurtosis, that means fat tails are more, so leptokurtic. So tails are the tapering ends on the either side of a distribution. They represent the frequency of values that are extremely high or extremely low compared to the mean. So in other words, the tails represent how often outliers occur. Okay, means by outliers, I mean exceptional data. That means your distribution is moving in a specific mode, but suddenly something happens, your data or data values will be either very high or either very low. So depending on that, your kurtosis is the measure of that thing, outliers. How often your situation goes abnormal. Okay, sure. Moving forward, this is what is the platycortic, mesocortic, and leptocortic distributions look like. So leptocortic is more tailed, that means your outliers are very often. Mesocortic means medium, and platycortic means your distribution is very stable. Summary was there. Okay. The summing around that today, what we have discussed? We have discussed the measures of variation. That means basing on our central tendency, if we are calculating only on mean, median, and mode, which will be representing your distribution by using a single number, but situation may so happen that your numbers, so that means the data sets are such that whenever you are calculating mean or median or mode, all the three variations will be coming out to be one and the same. In such situations, we require certain other measures like the measures of variation, which speaks about how means how your distribution is varying. That means what is the variation in your data set. And for that, we are having several measures of variations. And during this, we have discussed the measures as certain absolute measures and certain relative measures. The absolute measures, one is your range, and while defining the range, we said range is defined as the maximum value in your observations minus the minimum value in your data set. If the difference of the between the two is described as the range, and for calculating the range, we have taken into consideration two formulas. In one formula, it has taken into consideration the lowest limit of the class lowest class interval and the uppermost means upper limit of the uppermost class interval. And the difference between the two, we said that is one estimate, and the formula 2 is we have taken the midpoints of all the class intervals and the midpoint of the lowest class interval and the midpoint of the uppermost class interval. The maximum, that means U max minus L mean, we said the midpoint of the uppermost class interval and midpoint of the lowermost class interval, the difference between the two, and they have taken into consideration, and we have taken a data and we used both the formulae and make a calculation. And our calculation said that as for formula 1, we are getting a larger number, or the range is more in comparison to the formula 2. And we say that both the formulae are acceptable in statistics, and we can choose one basing on your data set and basing on your use. And number two, we said that coefficient of range, that is equal to L minus S by L plus S. L is the largest value minus smallest value divided by largest value plus smallest value. Then, which is the absolute measure of variation. Then we discussed the absolute mean deviation, average deviation or mean deviation, which is the mean, individual observation minus mean divided by n. And we have calculated basing on both grouped and ungrouped data for the same. And one more, just a minute. This one, I want to show you that this coefficient, and we have discussed one more, that is the relative measure corresponding to average deviation, and that is average deviation divided by mean or median. And then we discussed one more measure of deviation, or you may say measure of variation, that is standard deviation. We said that this is the most frequently used or most widely used or most widely accepted measure of dispersion. And this standard deviation, we have taken the formula for our population and sample as well. And we said that while calculating for the population, we are taking into consideration the size of the population, but while calculating in case of our sample, we are making 1n minus 1. Why we are doing that? To following the Bessel's correction to make our sample standard deviation corrected to n minus 1, to what you may say, to have the absolute estimate for our population mean. And we have taken into consideration the formula. We made a calculation on the basis of how we can calculate the standard deviation for ungrouped data and grouped data. And we had a detailed discussion about the procedure, starting from the frequency distribution. How can we calculate the mean? How can we calculate the deviation from your mean? And how can we calculate make the entire calculation by step? And then we have said the coefficient of variation, which is basically used for calculating, deciding about which score is more consistent, which is equal to standard deviation divided by mean into 100, and it is presented in ratios. And then we have discussed about the skewness, which speaks about the symmetry of your distribution, whether if mean, median and mode of a distribution are one and the same value, then your distribution is symmetrical. If not, then it is positively skewed or maybe negatively skewed. In case of positively skewed, that your tail of the distribution extends towards the right of your mean, whereas if in the case of this, negatively skewed, your tail of the distribution extends to the left. In case of your positive skewness, your mean is more than median and median is more than your mode. And negative skewness, in case of negatively skewed distribution, it is your mean is less than median is less than mode. And we discussed your skewness indicates whether your data are concentrated more on one side of the distribution or more on the other side of the distribution. And basically, your skewness is used to interpret income distributions, market returns, and business data. And then we discussed about kurtosis, which will be measuring the tailedness of a distribution. That means it basically speaks about how often your data set or your situation is going out of control, or what are the situations when your data is either becoming very low or becoming very high. That means this speaks about the abnormal conditions of your situation. So, and your kurtosis, maybe leptocortex distribution, maybe mesocortex distribution, maybe platycortex distribution. So, in case of platycortex, outliers are less. In case of your leptocortex, your outliers are more. So, this speaks about our measures of variation today. So, thank you.